Classical encryption techniques. It is broadly classified into two types. One is substitution techniques. Here each and every characters of plain text is replaced by another character. Next one is transposition techniques. The plain text characters are shuffled to get the ciphertext. The examples of substitution techniques are: one is Caesar cipher, second one is monoalphabetic cipher, third one is polyalphabetic cipher, which is further classified into Vigener cipher, Playfair cipher, Hill cipher, Burnham cipher. The examples of transposition techniques are rail fence and row column transposition. Let's see one by one. First is Caesar cipher. Here each plain text characters are replaced by another character which is standing 3 places further down. The formula is being used in Caesar cipher is: ciphertext C can be derived from the plain text value P plus key value K mod 26. Why we are doing mod 26? Because totally we are having 26 alphabets. And the inverse process decryption is represented as C ciphertext minus K value mod 26. See an example. Here the plain text is given as welcome. We need to perform the Caesar cipher. Before doing it, the plain text character, the alphabets are mapped with its numerical value, like A is mapped with 0 and Z is mapped with 25. To follow this, we may get the numeric values for each character as: for W 22, E 4, L 11, C 2, O 14, M 12 and for E 4. Here the key, as per the formula for Caesar cipher, we need to add the key value K to the plain text numeric values. So the key value K is 3. So adding 3, we get the values as 25, 7, 14, 5, 17, 15 and 7. Then finally we map the numeric values to the alphabets to get the ciphertext, which is Z, H, O, F, R, P, H. This is the final ciphertext for this plain text welcome. To perform the decryption process, the ciphertext is being processed to get the plain text. So the numerical value is taken and these values are subtracted from 3. So we get the values as 22, 4, 11, 2, 14, 12, 4. Again map these numerical values to the alphabet. So W, E, L, C, O, M, E. So finally we got the plain text. One simplest process. This is the actual procedure for Caesar cipher. The simplest process of decrypting the plain text in Caesar cipher is W. After that we are having the alphabet X, Y, Z. The third character is replaced for this character. For E, F, G, H. H is replaced for E. For L, M, N, O. O is replaced. Likewise, we can perform the encryption process. Monoalphabetic cipher. It uses fixed substitutions over the entire message, which means each and every alphabet has its unique mapping of another alphabet. Like A is mapped with T, B is mapped with I, C is mapped with U. Likewise, there is no relationship between these two characters. It's purely random mapping. For example, the plain text what comes around goes around is decrypted using this monoalphabetic cipher. We'll get the ciphertext output as AKTP like this. The hacker may easily guess the plain text because of the repetition of the word around. So the same word has the same ciphertext output, from which the hackers may easily guess the plain text. So that is the drawback of monoalphabetic cipher, and also they may use the diagram and trigram concept to hack the ciphertext. Another category is polyalphabetic cipher. It uses number of substitutions at different positions of a message, which means the same characters in the plain text will be coded as different characters in the ciphertext based on its position. The types are Playfair cipher, Vigenère cipher, Hill cipher and Vernam cipher. Let's see Playfair cipher. Playfair cipher is known as multiple letter encryption cipher. It splits the plain text characters into diagrams, that is, two characters are combined and considered as a single unit to perform encryption. It is also one of the types of polyalphabetic cipher. The steps are given here. This construction of key generation matrix of size 5 cross 5. To fill the matrix, we need to remove the repeated characters occurred in the keyword. After that, the remaining spaces will be filled with the alphabets. One more thing we need to notice here is the alphabet I and J will be considered as a single unit, so that we may get the 25 alphabets to fill the 5 cross 5 matrix. Second step is to split the plain text into diagrams, that is, two characters are combined and considered as a single unit. Then next step is the following three rules will be followed to perform encryption. When the two characters of plain text occurred in the same row, we need to follow the first rule, which is the characters are replaced by the next character in right side. If the two characters are occurred in the same column, the next character will be taken in the bottom side. Else we need to apply the box rule. Let's see an example. Here the keyword is monarchy. There is no repetition of characters in the keyword, so we just fill the characters in the key matrix. Finally, the remaining alphabets are filled in the remaining spaces, that is, A is already there, so omit A, B, C is already there, D, E, F, G, H is already there, I, J, K, L, M, N, O are already there, P, Q, R is already there, S, T, U, V, W, X, Y is there, Z. So that's all about the key generation matrix. Now we have to split the plain text into diagrams, like two characters are considered as a single unit. W, E. So we need to check where is the character W. It is in this position. And where is the character E? It is in this position. So these two characters are not occurred in the same row or same column. So we just follow the third rule, that is box rule. So we need to draw a box here. So for the first character W, in the W row, which character is intersected to the character E? So we replaced U for W, and for E, G is the intersection character for W. So W is encrypted as UG, and for L, C, next to diagram, L is here and C is here, same column. So L will be replaced by the bottom character U, and C will be replaced by the bottom character E. And O is here, M is here. So same row, next right side character will be replaced. For O, N is replaced. For M, O is replaced. And E is the single character, so we need to add one more character. So we may take any character. For this one, we will take X. So E and X, same thing. We need to apply the box rule. For E, the character is I or J, we may consider I. For X, the character is U. So this is the ciphertext value. You may notice that the character W is replaced by U, as well as the character L is replaced by U, and character X is replaced by U. So that this concept is known as multiple letter encryption cipher or Playfair cipher or polyalphabetic cipher. If your plain text is like BALL, so we need to avoid the repetition of characters. BALX, gap fillers are to be used. Here the gap filler is X, LX, LX. If the plain text character is balloon, then BA is taken. For L, to avoid the repetition of characters, gap fillers will be added, LX. Then here the L will be included to the next character O, so LO, ON. Next is Hill cipher. The main advantage of Hill cipher is it completely hides the single letter frequencies, which will be the advantage over ciphertext only attack, but it is vulnerable to known plaintext attack. The formula for performing Hill cipher is given here. Ciphertext will be produced by multiplying key value with plaintext value and performing mod26. The inverse process to get the plaintext, that is decryption, is done by multiplying K inverse with ciphertext value mod26. Here K is the square matrix, that means the number of rows and number of columns in the matrix will be same value. So based on the key matrix size, plaintext will be split. If the square matrix size is 3 cross 3, then the plaintext characters are split into 3. If the square matrix size is 2, the plaintext characters are split into 2. Let's see an example. Here the plaintext is given as attack at dawn, and the key matrix K is equal to 245921317. Let's take the first 3 letters ATT because of the key matrix size is 3. For ATT, these alphabets are converted into its numerical character so that we get 0, 19, 19. For getting the ciphertext, we just multiply the key value with 0, 19, 19. After performing mod 26, we get the value as 15, 5, 14. The numeric value is again mapped to the alphabet. We get the ciphertext as PFO for ATT. So the formula for finding K inverse is equal to 1 divided by determinant of K HK. Determinant of K is calculated and the value is 21. HK will be calculated by its cofactor values. So the value is given here. Then K inverse is equal to 1 divided by 21 and this value. So we need to calculate the plaintext value by using the formula. For K inverse, we just copy the same value, and then this is the ciphertext value 15, 5, 14 mod 26. Then just multiply these two matrices, we get 156 minus 303 1647, and then 1 divided by 21 mod 26 can be written as 21 inverse mod 26. The value for 21 inverse mod 26 is 5. That value is multiplied with 156 minus 303 1647. After that we need to perform mod 26. The resultant value will be 0, 19, 19. That is mapped to alphabet, so that we get the plaintext as ATT. I will share the process of performing K inverse in next video. The next polyalphabetic cipher technique is Virginia cipher. Here the plaintext is given as attack at dawn and the key word is given as lemon. First we need to check whether the key value size is equal to the plaintext size, else we need to repeat the same key value up to the last character of plaintext. So that attack at dawn, this is the plaintext, lemon is repeated until the last character of plaintext. So I just repeated the keyword. After that we need to add the numerical values of these two characters to get the ciphertext value. So the numeric value of A is 0 and the numeric value of L is 11. 0 plus 11 mod 26 is 11. Finally we get the ciphertext as L. Next is Burnham cipher. The formula for performing encryption as well as decryption is given here. Plaintext XOR key will be performed to get the ciphertext and ciphertext XOR key will be performed to get the plaintext. Here the plaintext value is hello. The numerical values of this alphabet is written here 7, 4, 11, 11, 14 and the key value is XMCKL. It is given in the problem. Again its numerical value is replaced. Then we just add these two values and performing mod 26 we get the values 7 plus 27 is 30, 30 mod 26 is 4. Likewise 4 plus 12 is 16, 16 mod 26 is 16. So we get the ciphertext as EQNVZ after remapping the numerical values to the plain text. One of the difference between Vigener cipher and Vernam cipher is here the key value size should be equal to the plain text character size. Next broad category of classical encryption technique is transposition cipher. The main difference between transposition cipher and substitution cipher is, in substitution cipher we just replace each characters of plain text with another character for getting the ciphertext. But in transposition cipher we need to rearrange the characters in plain text to get the ciphertext. That is, we need to perform shuffling of characters to get the coded value. There are two types in transposition cipher. One example is rail fence. Let's see. Here the plain text is given as meet me after the toga party, and the depth value is given in the problem. If the depth value is 2, we just write the plain text value in zigzag manner. So MEET, ME meet me, AFTER, THE, TOGA, TARTY. So like in the zigzag manner we need to write the plain text value. After that we just write the characters which are occurred in the first row and write the characters which are in the second row. This will be the ciphertext. If the depth value is 3, the same procedure will be continued, but we need to write the characters in with depth 3. MEE, TME, meet me. Okay. AFTER, THE, TOGA, TARTY. Okay. Then read the characters in the first row. THGR, and for the second row ET, EF, ET, EOAAT, and the third row EAR, TPY. Okay. Then the second category is, the second example is row column transposition. Here we need to write the plain text message in a rectangle, that is row by row. After that we need to read the message column by column manner. Let's see the example. Here the plain text is attack postponed until 2 AM. This plain text is written in row by row manner. So here the key size is 1, 2, 3, 4, 5, 6, 7. So 6 columns will be there. ATT, AC, 7 columns will be there. 1, 2, 3, 4, 5, 6, 7. Okay. We just write the plain text character without removing the repeated characters, because this is the example for transposition cipher. We just shuffle the characters, no need to remove the repeated characters. Remaining gaps will be filled by other alphabets like X, Y, Z, and then the key value is written here. Then based on the key value we just read the column. So first column letter is TTNA, second column letters are APTM, third column TSUO, fourth column AODW. So we just read the matrix column by column. For 5 COIX, 6 KNLY, 7 PETZ. Okay. And one more technique to securely transfer the message is steganography. The main difference between steganography with classical encryption techniques we have seen previously is, in classical encryption techniques the message is unintelligible to the outsiders, but in steganography it conceals the existence of message, that is the message is hidden to the outsiders. The types are given here. First is invisible ink. Here number of substances are used for writing the character, but it is visible until some chemical substances are applied on the paper. The second one is pin punctures. Here the characters will be visible unless the paper is held up in front of light. And next one is character marking. Here selected characters are overwritten in pencil. Until the paper is held at an angle to the bright light, it will not be visible. And last one is subset method. Here subset of characters or words are used to transfer the secured message out of overall message.